Opportunity Rover was a robotic rover that was part of NASA's Mars Exploration Rover mission. It was launched on July 7, 2003, and landed on Mars on January 25, 2004, in the Meridiani region. The primary goal of the mission was to search for evidence of past water activity on Mars, and to study the planet's geology and climate. Here are some key details and results of the Opportunity Rover mission. Landing site. Opportunity landed at Meridiani, a plain near the Martian equator. This site was chosen because it showed evidence of past water activity, such as the presence of hematite, a mineral that usually forms in the presence of water. Duration. The mission was initially planned for a duration of 90 Martian days, sols, which is equivalent to approximately 92 Earth days. However, Opportunity greatly exceeded its expected lifetime and continued operating for over 14 years until it was declared mission complete on February 13, 2019. Scientific instruments. Opportunity carried a suite of scientific instruments to study the Martian surface. These included a panoramic camera, a microscopic imager, a Mossbauer spectrometer, an alpha particle X-ray spectrometer, a rock abrasion tool, and a thermal emission spectrometer. Major discoveries and results. Confirmation of past water. Opportunity provided strong evidence for past water on Mars. It discovered rocks that showed signs of being altered by water, including the presence of sulfates and silica deposits. Endurance Crater. One of the major discoveries was the exploration of Endurance Crater. Opportunity descended into this impact crater, revealing multiple layers of rocks and providing valuable insights into the geological history of Mars. Ancient Martian environment. The rover discovered evidence that suggested Mars had a more hospitable environment in its early history. It found rocks with high concentrations of salts that could have formed in an ancient, shallow sea or salty lake. Meteorite discovery. In 2005, Opportunity stumbled upon a meteorite named Heat Shield Rock, the first meteorite ever identified on another planet's surface. Long-distance Opportunity covered a total distance of about 45 kilometers during its mission, surpassing the previous record for off-Earth roving set by the Soviet Union's Lunokhod 2 rover. Dust storm survival. In 2007, Opportunity endured a severe dust storm that lasted for months, reducing the sunlight available to its solar panels. The rover went into a low-power mode to survive the storm and later resumed full operations once the skies cleared. There are several challenges and problems that need to be overcome when conducting missions on Mars. Here are some of the major ones. Distance and communication. Mars is, on average, about 225 million kilometers away from Earth. This distance introduces significant communication delays, with signals taking anywhere from 4 to 24 minutes to travel one way, depending on the positions of Mars and Earth in their respective orbits. This delay makes real-time control of rovers or any other robotic missions difficult, requiring careful planning and autonomy for operations. Harsh environment. Mars has a harsh and extreme environment that poses challenges for both humans and robotic missions. It has a thin atmosphere composed of carbon dioxide, extreme temperatures ranging from as low as -195 degrees Celsius at the poles to highs of around 20 degrees Celsius at the equator during summer. Dust storms can also be a significant hazard, as they can limit solar power generation and obscure visibility. Surface conditions. The Martian surface is rocky, uneven, and covered with regolith, a layer of loose, fragmented material. This terrain can be challenging for rovers to traverse, with the risk of getting stuck or damaging their wheels. The presence of steep slopes, boulders, and sand dunes can further complicate mobility. Dust and sand. Mars is known for its dust storms and fine dust particles that can pose problems for equipment. Dust can accumulate on solar panels, reducing their efficiency, and settle on sensitive instruments, potentially hindering their performance. Fine dust particles can also pose risks to human health, as they can be abrasive and potentially harmful if inhaled. Power generation. Mars receives only about 44% of the sunlight that Earth does due to its greater distance from the Sun and the thin atmosphere. This limited solar energy availability can make power generation a challenge for missions relying on solar panels. Dust storms can further reduce the amount of sunlight reaching the surface, affecting the performance of solar-powered systems. Sample return. Future missions to Mars may aim to collect and return samples to Earth for detailed analysis. However, this poses technical challenges such as the safe retrieval and containment of Martian samples, launching them off Mars, and ensuring their safe return through Earth's atmosphere. Addressing these challenges requires careful mission planning, robust engineering solutions, and advancements in technology. Continued exploration and research on Mars will help us better understand and overcome these obstacles as we strive for more ambitious missions, including human exploration of the Red Planet.